Hello and welcome to The Complete History of Science. Series 6, Episode 6. Be Still My Beating Heart. In 1602, William Harvey returned to England and settled in London, a city which at the time had a population of around 150,000 and was on the cusp of becoming the largest in Europe. To Harvey, the thriving capital was the perfect stage on which he could pursue his ambitions. Immediately upon his arrival, Harvey aimed to join the College of Physicians. Despite holding a medical degree, it was crucial he apply, as the college granted the licenses to practice medicine in England. The College of Physicians was founded in 1518 by Thomas Linacre, a doctor and fellow graduate of the University of Padua. Linacre was its first president, who upon his death bequeathed his home, a tiny stone house on Knight Ridder Street, to the society. The purpose of the college was to eliminate the practice of unqualified physicians, apothecaries, or surgeons. It acted as the exclusive gatekeeper of who could practice medicine, which meant that a great deal of power was concentrated in the organisation. By joining this exclusive society, Harvey would not only secure his ability to practice medicine, but also meet influential peers, enhancing both his career prospects and social standing. To apply for membership, Harvey travelled to the modest stone house on Knight Ridder Street to present his doctorate. His application involved a rigorous exam, resembling a university disputation, during which his medical knowledge was thoroughly tested. The college was a highly conservative institution, which held the work of Galen in the highest regard. Harvey would need to demonstrate a deference to his authority in all medical matters. He would also be expected to be familiar with the latest translations of Galen. After his meeting, Harvey was told that his answers were entirely satisfactory and he could practice medicine. But he would not be admitted to the college at this time. Over the following years, he set up his own small medical practice, and in 1604 he married Elizabeth Brown, the daughter of the physician Lancelot Brown. This marriage was a boon for William's ambitions, as Lancelot was both a Fellow of St. John's, Cambridge, as well as the College of Physicians. No doubt recognising the great talent of his new son-in-law, Lancelot began to promote William within the college. Harvey's path to full membership in the college was still not straightforward. He underwent 3 more examinations, becoming a partial member in 1604, and only gained the status of full fellow in 1607. As part of the induction ceremony, Harvey recited the college statutes, which included a solemn promise never to speak disrespectfully of Galen. Harvey continued to advance in the college, becoming a censor in 1613. Censors were responsible for persecuting unlicensed practitioners. For example, they would check whether apothecaries were making proper medicines. Harvey, along with his fellow censors, would dress in their fine purple and gold robes and conduct raids of apothecary shops, looking for medicines which had been watered down with cheaper ingredients. If they found any, the medicines would be destroyed, and the shop owner arrested or fined. Harvey fulfilled this role gleefully, operating on the belief this was important work which would protect patients. While this may have been the pretext, the apothecaries were outraged. From their perspective, these laws were nothing more than an attempt to create a monopoly on the practice of medicine. Physicians could demand huge fees which the poor and sick could rarely afford. The apothecaries pointed out, quite fairly, that the healing record of the physicians at the time wasn't any better than their own. Harvey didn't credit this argument, instead believing the rules weren't strict enough. He petitioned the King's Council to ensure that a physician had to be present during the production of medicine. Harvey's new rules became law, which further infuriated apothecaries trying to earn a living. Over the following years, Harvey's career continued to flourish. Around 1609, Harvey became one of the primary physicians at St. Bart's, the oldest hospital in London. He secured this position through his connections at the royal court. His brother John was now a footman for James I. The Harveys had risen in large part thanks to their father Thomas, who had achieved great wealth, and through this wealth, gentleman status. The family acquired a coat of arms, and all of Thomas's children would inherit this rank. In 1618, Harvey became the personal physician to James I, solidifying the family's position in society. During the decade from 1610, William Harvey must have been immensely busy. In the day, he may have been working at St. Bart's, pursuing his private practice, visiting the royal court, or working on some college-related business. But interestingly, it's also during this period that Harvey was most fruitfully pursuing his own private research. Though on the surface, Harvey was an orthodox physician practicing Galenic medicine, he secretly harboured an interest in the most pressing new questions in anatomy. Harvey's interest in anatomy and physiology date from his time in Padua, where he had observed Fabricius's public dissections. After a long day, he would return home in the evening to the comfort of his small timber-framed house, where he spent his free time performing his own experiments. Harvey performed human dissections, acquiring corpses through his connections with the College of Physicians. This access was partially due to his appointment in 1615 as the Lumelian lecturer. In this role, Harvey became the public face of the college, tasked with delivering a comprehensive lecture series on anatomy, which included human dissections. These lectures not only gave Harvey a supply of corpses for experiments, but also informed the research questions he would set himself in private. Publicly, the content of these lectures was conservative. He gave a conventional synopsis of anatomy and physiology, frequently praising the great Galen, and rarely including his own opinions. In the lecture, he would have given an account of the heart, veins and arteries, which came directly from Galen. However, Harvey had some doubts on aspects of Galen's work. When discussing how blood moves between chambers of the heart, he stated, Galen believed that blood crosses the heart through the septum, and accordingly, many held the view that it is porous. But, in his lecture notes, he wrote a cross after the word porous, followed by the name Columbo. This was in reference to Rialdo Columbo, who had suggested that blood instead passed through the lungs, what became known as pulmonary circulation. Columbo's theory piqued Harvey's curiosity, but rather than take him at his word, he decided to investigate the matter for himself. Galen, as Harvey noted, had argued that blood passes between the heart's chambers through tiny pores in the septum. This had been cast into doubt by Vesalius, who found no evidence for these pores. Vesalius' student Columbo had suggested an alternate explanation. Blood flows from the right chamber of the heart through the pulmonary artery to the lungs. It's then carried back from the lungs through the pulmonary vein to the left chamber of the heart. In order to resolve the truth, Harvey devised an experiment. He tied off the pulmonary artery in a human cadaver and then placed a tube into the right chamber of the heart through the vena cava. This allowed him to inject water into the right chamber of the heart, mimicking the inward flow of blood. When he pushed water into the heart, he found that no matter how much force he used, no water passed between the chambers. This seemed to imply that Galen was wrong, that there were no pores between the chambers. To check, he repeated the experiment with the pulmonary artery untied. This time, he found that a great quantity of water entered the other chamber. This confirmed that Colombo had been correct. Blood passed between the chambers of the heart through the lungs. Harvey's research interests had been inherited from the Paduan anatomists. In particular, he followed in the tradition of Fabricius, whose dissections Harvey had witnessed in person. Fabricius himself was a follower of Aristotle, and his aim had been to continue Aristotle's research. This was a broader conception of anatomy than had sometimes existed during the period. The great Vesalius's work had primarily been to correct anatomical errors in the human body. But Vesalius had made very little progress in understanding the functions of the parts of the body. Fabricius's research, on the other hand, explicitly aimed to better understand the functions of the organs and their purpose. Further to this, Fabricius didn't want to just understand the human body, but rather, in a more abstract sense, to understand how animals worked. More so than any of his contemporaries, Fabricius treated animals as a legitimate object of study. Harvey, the heir of Fabricius, filled his humble home with a great barnyard of various animals. He kept cages of fowl, mice, rabbits and geese, as well as buckets of toads, crabs, fishes, oysters and whelks. He also had kennels where he kept larger animals such as sheep, pigs and dogs. Working with animals had practical advantages. For one, they were far more readily available than human corpses. But just as importantly, it was possible to perform vivisections on them. That is, to cut the animal while it was still alive. This became one of the key features of Harvey's research. Buoyed by his success confirming pulmonary circulation, Harvey turned his attention to the motions of the heart. The heart was known to act like a muscle, but there was debate over which was its active phase. That is, when did it generate tension? Galen said expansion was the active phase, whereas Colombo argued that it was contraction. This question may not seem to be very important, but it was closely linked to ideas about how blood moves around the body. The Galenic view was that as blood left the heart, it did so softly, and instead it was the pulse of the arteries which transported blood away. Colombo's heart, on the other hand, contracted with a lot of force, causing blood to be ejected quickly. To resolve this question, Harvey began to perform a series of vivisections to watch the beating heart of animals. The earliest of these he performed on larger animals such as sheep and dogs. Unfortunately, it was tremendously difficult to resolve the heartbeat, as it's too fast to observe. According to Harvey, the expansion and contraction of the heart was accomplished in the twinkling of an eye, coming and going like a flash. He did note that in dying animals the heartbeat slowed, and it appeared to Harvey that the blood was being expelled forcefully as the heart contracted. But as the animals kept dying so quickly, he couldn't be sure. This question was clearly pressing on Harvey, and he referred to it during the Lumelian lectures. When presenting Galen's theory on the function of the heart, he also referred to Colombo, explaining that Colombo regarded the heart as responsible for the motion of the blood. Harvey also mentioned that he made his own observations of the heart during vivisection, and he was inclined to take the side of Colombo. This was a bold move on the part of Harvey. The conservatism of the College of Physicians could not be overstated, and by criticizing Galen, he was opening himself up to attack. Fortunately, these comments seem to have only raised a small stir. Afterwards, he discussed the theory with some younger members of the audience, but there was little outrage. In the dinner, which followed the successful end of the lecture series, Harvey was toasted. Harvey, though, wasn't satisfied with his own work on the motion of the heart. His experiments on larger animals had mostly been inconclusive, so he began to broaden his approach. He looked at cold-blooded animals and observed that their hearts beat much slower than in mammals. His first experiment was on a small fish, which the English would call a shrimp. It was too small to dissect, but luckily its little body was transparent. With the aid of a magnifying glass, Harvey could watch its heart expanding and contracting. He became convinced that he could see blood being pushed out through a pipe or artery as the organ contracted. He continued his investigation by dissecting a larger fish. Cutting open its writhing body, he observed that when it contracted, the heart became firm to the touch. Harvey knew that when muscles were in active motion, they were tight, and said that the fish's heart felt like a muscle in contraction. Again, though, Harvey wasn't able to completely convince himself, as the fish died quickly after it was cut. To expand on his research, Harvey returned to experimenting on dogs. With the help of a servant, Harvey tied down the dog and opened its thorax to watch its beating heart. As he observed the heart, he believed that he saw blood being drawn into the heart via the vena cava. When the heart contracted, blood was expelled and pushed into the pulmonary artery. To confirm this, he tied off the vena cava and noticed that the blood supply was quickly cut off and the artery emptied. This satisfied Harvey on the direction of the flow of the blood, but he wasn't finished. Galen had suggested that the pulse was an innate feature of the arteries. That is, they expanded and contracted on their own accord. In this model, the heart draws blood inward towards itself, but it's the pulse of the arteries which acts on the blood and causes it to be transported around the body. Harvey tested Galen's explanation. He tied the dog's main artery, the aorta, and found that this caused the pulse to cease. As the blood built up, it caused an enlargement of the left side of the heart, and it almost ruptured. Harvey concluded that the pulse was simply an expansion of the arteries, caused by the heart expelling blood forcefully outwards. Although he would never use the analogy himself, the model of the heart that Harvey was building was fairly clear. The heart was acting as a pump. Blood entered the heart from the vena cava during its relaxed phase while the heart was expanding. When the heart contracted, it pumped blood through the pulmonary artery to the lungs. As the heart relaxed again, the blood returned to the other chamber, before another contraction pushed it forcefully outwards to the arteries and the rest of the body. This model seems to have clarified in Harvey's mind by the middle of the decade, but there were still questions left to answer. Harvey could see that a large amount of blood was being ejected from the heart. The question was, where was all this blood going? And what's more, where did all the blood come from? Harvey was not one to set these questions aside or to leave it for someone else. He was still young, and by now an influential voice in the medical profession. In the next episode, we'll follow this question as it leads Harvey to his most important discovery of all. Until next time.